Welcome back. We're well into spring here at Moonlight. We're 7 months into construction now. The windows are in and our airtightness layer is in the final finishing touches. Insulation, the first layer is complete and we're getting ready for our plumbers and our electricians. If you think about our whole structural build up and then you have a hole in the wall essentially and you're putting you're getting rid of all of that insulation, that depth, and then putting a window in. So triple glaze is really important in preventing that heat loss. And then also you've got a non-conductive material like UPVC, or another really good material is wood, is that it lessens the impact of that window heat loss. Whereas aluminium, as we know, is very, 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 very conductive.
Aluminium is one of the biggest conductors of heat, which is why we use it for our pots and pans, and we put it around our windows. So ultimately, we're consistently losing the most heat through our windows. And obviously, everyone wants big windows in the beautiful place that we live. But the traditional New Zealand window, which most houses have, basically has a really poor frame. It's built outside of the envelope, which is what E2 tells you to do, is to put the whole window outside of the envelope. So even when people spend more and get, say, a thermally broken frame and fill the cavities with argon or put Lowy on the glass, so they've spent extra money to get this better frame and better window, it sits outside of the envelope, so everything around it is leaking heat because you've got your insulation back here and your window out here, and you've got all these gaps all around it.
The way we're installing our windows is we're recessing them, and what I mean by that is we're pushing our glazing back into the framing line. So our glass is our thermal resistant layer. We've got that in line with the rest of the insulation in our wall. In the New Zealand Building Code, standard practice is to have your window sitting outside of your building line, and then your cladding tuck in behind the flange. So your window's out here. So essentially, you're bringing your resistant layer in the glass further out, and then it's in the outdoor environment, and then you increase the risk of condensation, mold. You decrease the performance of the window. Thermally broken windows are being used more commonly in New Zealand now, but they're still being detailed as sitting outside of that insulation and building line. So you're defeating the purpose of that thermal break. Our windows are supplied by Envelop in New Zealand, and they're Neuffer triple glazed UPVC framed windows. As we know, with going from single glaze to double glaze, and we've got encapsulated space for air, or now with the likes of argon filled gas, we're adding another resistant layer to heat loss, or in the summertime heat coming in. So if triple glaze, then we add another layer. You also get further benefits with sound, with soundproofing. That's why now we use triple glazing.
Triple glazed German windows. Aluminium, durable, but we've only got it on the outside layer. Then we have UPVC, which is non-conductive throughout the whole thing. And then, we've got this steel member that adds all the structure because of its strength. So we're like using everything for what it's good for, but isolating it.
So if you think about passive house principles, and then you look at this window and everything being continuous, we're hitting our airtightness of 1, 2, and 3 seals. So this is the external face. We've got a seal there. Then as that closes, we have another seal closing in on here. And on the internal surface, we have that there.
And then We've got these off-center cams which run, there's one here, there's also another one or two on the bottom and on the back edge. And as you spin that round, that brings this window closer to its seal. So we have two seals here. As we close that and lock that, that locks all of those cams in against the window and seals that. And that's where it's key to have good performance there, because that's where you'll lose air in your air tightness. So air sealing in our windows is really important. Now, if you start to kind of put things together and we're talking about those principles, you can see all those principles being applied in this window that we're applying in our build. We've got thermal bridge-free construction, we've got air tightness, we've got the best insulation you can kind of do when it comes to a window frame, and then using that triple glazing as well. So really, it's like a passive house in a window.
So essentially we have 3 layers of tape here. The first layer of tape sticks to the interior of the intello inside the building. Then the second layer we have here, this black Contega EXO, sticks on the outside, the exterior of the building for a weather-tight barrier. And this is basically an extra layer to stick on the inside of the intello.
Normally none of this tape would be on the window as an air seal. Normally there'd be a timber reveal on your traditional window and you'd fix through that into your timber frame. But then the only thing essentially between the outside and the inside is a layer of spray foam to try and seal it up. But having what we've done, 3 layers of air seal, it's much better performance than what you'd normally get out of a traditional window.
Because we want to get a good, air tightness score on these windows, so we've got these membrane tape and tapes taped to the side of the window. That comes out, and then we tie that in, and then it's continuous with our intello. The other really key thing about it is that it's also, vapor control. So we're stopping vapor going through there. And on the outside, it's really key as well, because you need to do the same and tape the window and wrap that vapor control layer, that weather barrier, to the outside. If we just did this on this side, didn't do it on the other side, that vapor would try and come in, it'd track through, and likely as you would still have like a moisture build up in there. We're protecting our insulation so it can continue to perform. We've got that same weather resistance barrier on the outside that's stopping the moisture ingress. We're stopping the moisture ingress here from going in. We're controlling all that moisture inside with our mechanical ventilation. And then we're protecting this insulation so it can continue to perform. We're using Terra Lana's wool insulation. The benefit of wool is it allows the absorption and release of water vapor. I like to wear like a merino top on an evening where it's quite warm, but I know it's going to get cool, because it'll handle, say when I'm riding, it'll handle the sweat and the vapor, and then it'll release it and dry out, and then still keep me warm as the sun goes down or the evening gets cooler. I've got a moisture meter, and we know that the timber content's about 20% at the moment. We're putting this wool in before we do our intello. So this timber is going to continue to dry out, and with the wool insulation, it can handle that vapor diffusion. If this was fiberglass and your building environment is drying out, and nearly every home isn't airtight with a vapor barrier internally, so stopping that vapor going through the wall,
you just have constant vapor, moisture going in and out of your wall cavity on a typical New Zealand home. And fiberglass doesn't handle that vapor diffusion, and that's why slowly your insulation over the years decreases its performance with fiberglass, whereas a wall can handle that and will continue to perform. So the difference is, because the wall can handle that absorption and release of vapor, all this is going to do is dry out from now. But with the fiberglass material, it'll absorb that moisture and then won't release it. And the awesome thing about Terra Lana wool insulation is it's again using a product of sheep wool in New Zealand, so it's feeding another industry. So we're not importing, fiberglass material or other insulation. We're just supporting a New Zealand-made product. You're reducing your carbon footprint, and there's more embodied carbon going into your home. These colourful parts are recycled wool from carpet manufacturers. Terra Lana will take their offcuts, tons of excess wool, and then use it in their insulation. So that's why you get all these different colours, so there's an awesome element of reuse and preventing something going to waste. A really awesome thing about working with Terra Lana's wool insulation is they will recycle the offcuts. So we'll bag these up, send them back to them, Corey will pick it up, and it's a small charge on our behalf, and then that goes back into production and they reuse these offcuts back into their insulation again. So far better than glass insulation. Fiberglass insulation literally gets bagged up like this and then put into landfill. So we would happily pay the fee to see this reused rather than be chucked out. So now we've got our Intello, our Airtightness vapor control layer, and then we're doing a service cavity. So this way no services are travelling through our insulation layer, the main one in those walls that we saw, and they can wire and plumb the whole house through this cavity. And we've left actually a gap down the bottom so that if they need to run along quickly, they can get along there, and then that prevents them having to drill holes and risk of hitting our membrane and putting holes in it. So small things like that where you can kind of assist your sub-trades in protecting this. And then we add another small 45mm amount of insulation, but it just increases our total R value in our walls. Up here we're getting ready for our ceiling framing. This is going to have rondo, and we're dropping that 140mm so that we can run all our ductwork. We want all our ductwork in the conditioned space. So now our mechanical ventilation guy can run all the ducts through here and get down, and we've got a passageway down at the mid floor, but you're starting to see how we're dropping that ceiling. We're screwing up into our trusses through the Intello, but we've got the Contiga air seal from Proclima, so we're sealing those holes as well as we go. It's week 28 and we are filming the blower door test. We are testing how airtight the building is, and we're hoping to achieve the passive house standard, which is under 0.6.
And what are you hoping to get?
The Jack said if we're under 0.2 we're on the beers, but under 0.6 we're happy. Yeah.
So can you tell me what you're doing?
We have the WinCon machine from Proclima, and we're going around doing a pre-check before the blower door test. So we can go use some smoke and we can bless this building. But go around and check for any leakages. We're not expecting to find anything, but we'll see smoke draw, or you can use the back of your hand. Yeah. So, demons be gone! Demons be gone! Found one.
Just find one.
So if you see, obviously you can't do anything about the door, but you can see the smoke. Super stable. Super stable. Well, you obviously can't get zero, but you'll have small holes, so like obviously a keyhole we can't really do anything about. This joinery is pretty airtight, you know. So we have one there, which we knew. But then if I go down here, you know, we're not getting any of that, or like through wall penetration, can't even feel that. And that goes to the outside. So you'd think it'd be through those penetrations or something, but
Looking good.
nothing. So that's where we put that that connection strip in that frame, like in the middle of winter.
Mm.
So Nigel's the expert. We just did the wind con again with him. He just checked some areas, did his check to seal windows, check pipes, we've capped all of those, and yeah, and then now he's going to set up his blower door, which then he hooks into his computer and starts reading the test. So
there's a little computer which measures the airflow through the fan, which has various size holes, so it has a measurable capacity and it's giving a proportion of that capacity, and the computer converts it into some data that the software then converts into cubic meters per hour, and that cubic meters per hour is related to either the volume of the building or the envelope area. The volume of the building is all the air internal space that you actually breathe, and the number we're aiming for is the number of times that volume of air is changed every hour. Passive house requires 0.6, which is an ideal, because if you're heating the air inside a house 0.5, for example, per hour, that's every hour you have to heat that volume to the temperature you want. Half of it every hour. So if the building is a 1 air change per hour, you have to heat the whole volume of that air. In this building, it's around 400 cubic meters of air, which you're trying to keep warm, so you're comfortable inside.
looking good.
Great. This is provisional because I still got to do the check dimensions and stick it back into the box and make it happen. And
0.25. Ha-ha.
Get in, lad.
Sick.
So close to being on the beers.
It's nearly on the beers big time. But
what was it on?
we said under 0.2.
Oh, very good. Well, that's great. That's a great result.
That's awesome.
It's only halfway. It's only halfway through.
Yeah.
So pressurise and see if it's going to change.
Yeah.
Oh, yeah.
Were you expecting that?
Oh, yeah.
I don't know.
Quietly confident.
Quietly, I think. I could see us getting a good score like that. So, yeah. No, it's real good.
Put all the hard work
Makes all
in.
the hard work worth it. All the times you're like, should we do that or is that ridiculous? Not so ridiculous now. Oh, 0.17. Who's got on the D? Oh, 0.21. We're on the beers.
And that could possibly change by 0.01,
Yeah,
depending on how good my measuring was.
yeah.
But anyway, otherwise, fantastic result.
Awesome.
Well done.
Thanks, Nigel. Sick.
Team.
Yeah.
Cheers, mate.
No, that's awesome. Well, we were saying, I was like, I reckon we could get 0.35, and
Yeah.
Jack's like, shh, don't say anything. Good shit.
Okay, brother.
Well, there's definitely some junctions in this that are like great, you know, that were harder to detail, and then it's like traditionally framed, so like timber frame, rigid air barrier, weather resistant barrier outside an Intello, like it's all been, you know, the reason for a good air tightness score is like all of the hard work that the team's been doing. So, you know, we've applied this everywhere in like every junction, whereas definitely like with like a sit panel house, for example, you're just getting a really good performance just in that wall already. Yeah.
So this type of construction makes it more of a challenge.
Yeah, slightly more, and the increased amount of effort and thinking, like with our windows, we did a really good job. Like that pays off.